Okay, so this is me, my beginning slide. And what I wanted to start with is to transport you to this wonderful mountain. How many people have seen amazing skies when you're in a high mountain somewhere? It could be even in Chicago, but usually in a high mountain. I think everybody, right? So I think this is one reason we love what we do, is that the awe part of it. You just look out there and you're like, wow, okay? Now, those of you who are, really studying astronomy in the room, can you tell me where, if you could see this image, where this image was taken from? If it's southern hemisphere or northern hemisphere? Any guesses? Yeah? And why do you say that? You don't know? These two things here. Yes, so she's completely right. So this is the southern hemisphere. And in the southern hemisphere is where I'm from originally. So if you don't know where I am yet, because it might not be written there, you have to guess at the end of my talk. All right, so this is the southern hemisphere, and these are the two Magellan clouds. And this is, Magellan went around Africa and found them. They were there before him, obviously. And that's what the Magellan telescopes are named after. You can also see a comet, which was very exciting for astronomers way in the 1700s, and the Milky Way. Now, let's go further. This is a different type of image. So this is a galaxy, and you can see some jets coming out of the center of the galaxy. So this is a much more violent place in the universe, but you wouldn't know just by looking at it with your eyes. So here's actually a decomposed image of what you just saw. So this is the image with your eyes, meaning with the visible light that Wendy uses. If you use radio telescopes, you would see only the jets. You would not see the whole galaxy. And this is with the X-rays, which are very high energy light. So there's very different, like the piano, right? There are many different keys, many different wavelengths or frequencies. That's the same thing with light. And we can see many, many pianos in every direction, lower key and higher key, much more than the piano. So we use all of that to understand what's going on in these very exciting places in the universe. In this case, we have 55 million solar masses, which means 55 million times the mass of the sun, in a black hole in the center of this galaxy. And it's spewing out these jets. These jets of particles might come all the way to Earth. This is the smell of the universe part, right? So she's looking at the universe, I'm smelling it, I guess, catching particles, and Vicki will tell you about sound. All right, so and what we mean by trying to smell the universe or touch the universe is that the universe is not just light. We hear matter, and what we see in the universe through light is matter, right? So this is galaxies, many galaxies. This is called a cluster of galaxies, but there's a lot more there than you can see. Okay, so there's a lot more mass, a lot more matter, and this is where the dark matter story begins. So in the 30s, it was clear already by people like Fritz Zwicky that these galaxies are moving around each other much faster than if they didn't have this dark material around. So if you want to imagine it, this is an image of our galaxy with this huge halo of dark matter around it, which we actually don't know what it is. We know how it's distributed. It could be a lot of lost socks or umbrellas. Have you all lost socks and umbrellas? Maybe that's what the dark matter is. Or it could be particles, which is where, catching them is what we try to do. So what I do, I'm more of a physicist in the sense that I learned particle physics first, and then fell in love with the universe when I was doing my PhD. So I didn't start as early as Wendy in the universe. I was trying to understand how things work. And, you get to learn about the quarks and all the pieces of matter in this room. And then you learn that most of the matter in this room is not what we see either. Okay, so the dark matter is coming right through this room, and we're trying to catch these particles. To do that, this is actually a simulation which shows what the dark matter structure in the universe would look like. So instead of those galaxies that you see, just those, let's go back for a second, these blue things, galaxies, there's actually a spider web which goes that basically connects all the galaxies with these web-like structures, and this is what the dark matter looks like. And we think they're particles. So we are building many, many telescopes. We actually know that there's also not only dark matter and ordinary matter, but there's also this dark energy, which we really have no clue. So the younger ladies here, please, we need you. Go figure out what this is. We have no idea. All right, so this is one telescope that I got involved in 1995. We built this telescope in Argentina, in the Pampas Amarillas, And this is one of the detectors, and we deployed 1,660 of these. And this is one of the telescopes that overlooks this array. So this is one of our lonesome detectors with the Andes Mountains in the back. So what you're seeing here is not super sharp, but it's a lot of yellow little things and one particle. So this is a very high energy particle that comes from some galaxy far away, reaches us from one of these galaxies probably that have these jets, reaches us and makes a whole shower of particles. And if we go back and do that again, that would be lovely. And the detector, so the telescope, is really detecting particles as opposed to light. But the way that we end up detecting particles that come through these detectors on the ground, the Andes is over there, and this is 3,000 square kilometers. So it's a huge area that we filled with these detectors. And we used 19-country collaboration to do that, and it was a lot of fun. Now I'm leading this baby here, which is a telescope to be put on the space station. And the idea is to do more, 2 orders of magnitude, so 100 times more observations of the particles. So these are what the particles look like. So there's one particle, a tiny little proton, so something that comes from matter, that is so energized that it creates all these other particles on the way down, and we can see it with a telescope looking down. So we designed this telescope, and we built with about 13 countries, actually 16 now, a collaboration. This is a little prototype of that telescope, and it goes in a balloon. And I would love to jump from it. I've bungee jumped from a balloon in my life, which is really fun. The graduate students have all the fun though now. So you have the balloon going in at night around this. We did a test for one night, and the helicopter goes underneath it and makes a fake shower. So this is what we've done so far, and we're now getting ready to have a flight which would take months going around the Southern Ocean and detecting these particles. Okay, so this is what I've been working on. And this is a little video which might work. Can you check if it connects?
Sound on this one or no?
No sound, right?
No sound. Actually, it doesn't matter this one. The other one I'm talking at the same time, so it's a little funny. Good. Well, I'll tell you the history behind this while we're seeing the video. So this idea, so when you work on the edge, like we do, the 3 of us, we work with large collaborations. We have to do all kinds of interactions that are interesting. I love it. You fly all over the place. You get a lot of miles. Executive platinum, if you're an American. Anyway, and you also need to deal with issues that happen. Okay, so this project had a very interesting history. It started in 2000, and it was going to the space station with the shuttle. Do you remember the shuttle? Maybe some people are too young. But there was such a thing called the shuttle that would take big things to the space station. And then the shuttle had an accident that was very sad, and then we canceled the shuttle. So what happened with our project, and if this thing clicks, you will see, it got redesigned to go up with the Japanese. So the Japanese have another delivery system, because those who actually go to the space station, for example, the Russians, they have very small spacecraft that people go up, but not big telescopes. So we had to redesign it for something like the HTV, which is what you see here, which would, join. Can we get the word? Strange. Oh, well, there it is. Yeah, okay. So the HTV would duck, and then we would have this arm. Okay, maybe not. All right, well, anyway, technical difficulties. We can build telescopes, or we can't make PowerPoint work. Anyway, so this baby here, which is the HTV, is now, the best way to get to the space station. However, you heard about Fukushima? Well, the Japanese are canceling the HTV. So now we're in trouble again, because we can't get a ride. We can build a thing, but we can't get a ride. So have you heard about Elon Musk? Yes, so he's our savior. So now we've redesigned this for the SpaceX delivery. So we're hoping that that will work, that he doesn't have any more accidents. He had one, but hopefully that's just a glitch. And then we get the baby up there, okay? Now, if none of this works, what we're doing now is actually redesigning it to be a free flyer, because we don't need to deal with the international collaborations to that matter. But we had a few interesting events, let's put it that way. Actually, the Russians decided to lead it for a while, and then there was the invasion of Ukraine. That didn't help. So anyway, so I just wanted to add to our conversation that doing what we do is not only really exciting in terms of understanding nature, but it's also the fact that you run into people in 19 countries or 30 countries all over the world that with different cultures, with different ideas, different religions, they all want to find out the exact same thing that we do. And that really is super exciting. So anyway, thank you.